Good morning. So back in the basement, and I want to point something out to everyone. You have made it to the last lecture of week 3 of online lectures in CSI 121. Congratulate yourselves. This has not been easy. It's not easy to stay engaged. It's not easy to continue to work. It's not easy to continue to listen to me drone on without any interaction, without any ability to ask questions. This is tough. This is not an easy job that either I or you have had thrown in front of us. This virus is making everything tough. I have been in self-isolation for 16 days now. I'm recording this actually Wednesday night, so 16 days. By the time you see this, it'll be 17 days. 17 days since the last time I had a face-to-face conversation with someone other than my wife. Now, my wife is my best friend. That's why we've been married for 32 years, almost 32 years. And, I am glad that I am self-isolated with her and my cat, but it's difficult. It's really difficult. I did say hello to a neighbor who was walking the other day from about 15 feet away, the width of the road, basically. We were on one side, she was on the other. It was sort of like, hi, we're just going to keep walking. So again, difficult times. We are looking at, the end of the 3rd week of online courses, and we have 3 more weeks before finals week. So by the time we get to finals week, we will have endured 6 weeks of online instruction. Now, yesterday was a bad day for me. Today, Wednesday, was a bad day for me. Hopefully Thursday, when you're watching this, is a better day for me. I got really frustrated the last couple of days. Things not working the way that I felt that they should. The world not working the way that I felt that it should. So, with that said, I would like to invite you into some code. So today, or Wednesday's lecture was basically going back to the linked lists and talking about linked lists a bit more. We'll pick that up on Monday. Your last program in the course will be a linked list program. Your current program in the course is a queue program. And so what we're going to look at today is a little bit of test code. Excuse me. It's actually kind of late at night, and my days typically the alarm goes off at about 6:30 or 7 in the morning. Today I set it a little later, 7:30, because I didn't have a 9 o'clock meeting. And then it finishes at about midnight. And when I think I have it hard, then I read on social media what our healthcare workers are going through. I have healthcare workers that are, relatives that are healthcare workers. My mother-in-law was a nurse. I have a really good friend who's a nurse. These are tough times for people in the healthcare field. So appreciate them, because one day they might be the only thing between you and having this virus take you out. So, yeah, round of applause for our healthcare workers. So I'm going to drop video now, and I'm going to share out a screen, just a, the usual. So I have, obviously I've been doing some work here. I'm going to go into test.cpp. Okay. And so in here, I've just, I've got some test code, real simple, just to make sure that I can allocate app data classes, and I can allocate a queue class or a queue object that uses the app data. And so I'm just going to walk you through up here. Right up here, I include IOStream. Then I include the C-string library because I have to do some mucking around with strings. I include appdata.h, which is my specification for a shopper. So this is got the shopper's last name, it's got whether or not they're a valued shopper, and it has the items in their cart, no more than 21 items. Could be less. And then it's got a piece of private data that nobody sees and nobody really can, well, we are going to affect it. There's going to be a setter and a getter for it, or a mutator and an accessor. So it's got the number of items in the cart as well. So, okay. The queue class I'm doing is not the queue class precisely that you are going to need to develop. It's most of the queue class that you need to develop. And so I'll be posting an addendum to the program. What I want you to do for the queue class is to convert print queue, which is what I showed you originally when I did the example queue class. If you remember, this is like, COVID days. This is like 30 days ago now, when in fact it was maybe just the start of this week, or maybe it was Friday of last week. I took the stack class and I modified it to create a queue class, and it was a pretty straightforward modification. But that had a print queue in it, and what I want you to do is take that print queue and convert it into the stream insertion operator overload, so that we can just say C out and then like my queue, and my queue will print out. Okay. And so in here, I've included C-string, I've included appdata.h right here, and I've included queue.h. And so that's that queue class that, that I built out of the stack class. So be watching for a new program 7 clarification that'll tell you exactly what you need to do in your queue class that is a little bit different from what I had done in the examples. Using namespace standard, sort of typical. And here I've got a shopper that I'm calling temp-s for temp shopper. And then I've got a queue class called myQueue, okay? And then I've got a local variable, which is a C string, T name, temp name. Okay, and I'm using that max name length +1. So I'm going to test the last name mutator and accessor. Okay, and so I'm going to set the last name to Smith. This gives me a warning in the compiler because it's looking for a reference to a string, and this is actually a literal string. So the literal string doesn't have a place in memory or a reference for it. And so the compiler is going to whine at me, but it's just a warning, and everything actually works the way it's supposed to. Then this is a weird little piece of code, and this works. What it's doing is it's saying, get me the last name from that app data, that temp_s. And so that's just going to bounce back Smith back to me, and do a string copy into tname, okay? With the maximum of max name length characters being copied. So it's an strn CPY. And then I'm going to output that tname, and we're going to see if that actually works the way that it should. And so this is a way for us to get the name out of the object, the app data object. Passing arrays back and forth, arrays of characters, arrays of ints, is actually dicey stuff inside of an object. It's not easy to do. And so that's why I am giving you the code for doing this. And then I print out that name, and then I test the stream extraction operator right there, okay? Or stream insertion operator, sorry, to print that thing out. And since there's nothing in the cart, we're not going to see anything. It's going to say 0 items in the cart. The other thing I'd like to do here is to print. Why am I writing Python code? Holy smokes. Cout my queue dot is empty. Okay. Now this very much should be empty, but it tests to make sure that that the queue was created correctly and was initialized, at least as far as being empty, was initialized correctly. And so with that, I'm going to go back in here and recompile. So there's my compilation. There's my warning that says deprecated conversion from string constant to char star. Okay, so that string constant is right here. And the thing that's the parameter is actually a reference to or a pointer to a C string. So it's looking for the name of an array. And so these don't work, but this is deprecated, so it converts it, and it works for us. So now I'm going to run this code, and my virus scanner has to run, and it has to say, no, you didn't put any viruses in this. And there we go. So shopper Smith is not a valued shopper, and the cart contains 0 items. That printout of Smith was, I got to go find why this printed out. But the value returned from is empty is 1, which is true. And so is empty is working for the queue as well. So let's go back into that code. What did I do? Oh, I couted the name that we got back from the accessor. So that worked. I really don't need to see that again, so I'm just going to delete it. Okay. Now I'm going to test a little bit more. So right here, I'm going to put in some code test the cart mutator. Okay. And accessor. Okay. So temp s dot set I think it's set item num, and I'm just going to put in 3 items. Okay. So I want to get out of here and make sure that that set item num was exactly what I wanted. So cat app data.h, just take a look at it here. Oh, set cart, num, and contents. Oh, I set this up to take an array of item numbers. Ha! And then this is the number of items in the cart. So I need to go back into test.cpp and clean that up. That is not. So this would be set cart. And then I need an array, and I'm going to call it my cart. So I'm going to go up here and define that. Int my cart. And that has max items as its size. And I'm going to use an initializer in here. And I'm going to initialize the first 3 items to valid item numbers. So there we go. So let's recompile that, see what happens. So we're still okay on the compilation. And let's look at the execution of that. Wait for my virus scanner to run, blah, 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 blah. No, you didn't insert a virus into this file. And hey, there we go. So my, my stream insertion operator overload is working for app data. That looks good. Now, I could enqueue that, and that would allow me to test my print queue as well. So let's do that next. So back into here. So right after the print queue is empty, I'm going to do myqueue.enqueue temp s, and then I'm going to see out myqueue.isEmpty to test to make sure that that's been set to a false value, which should be 0. And then I'm going to do myqueue.printQueue. Okay. So let's compile that and run. Undefined reference, shopper const. So this is giving me grief about the constructor. So the constructor for a shopper. So right here on the enqueue, I've got this temp s, and this is invoking the copy constructor. So my problem is actually in the copy constructor. And so sure enough, there's undefined reference to shopper const. Okay. So here we go. I'm going to look at appdata.cpp, and I'm going to look at our copy constructor. Oh my goodness. So here we go. Does anybody notice what's wrong in here? What's wrong is there is no copy constructor. I forgot to write one. hence the undefined reference. So the copy constructor, okay, is going to look just like the equals operator, the assignment operator. So the copy constructor is going to do a const shopper reference shopper colon shopper const shopper ampersand original. Okay. And then pretty much we just need the code from down here. So I'm going to go down here. Let's get rid of that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I want to get 13 lines. So I'm going to grab those 13 lines and then I'm going to paste them in. And so RHS now needs to become original. 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 And original. Okay. And then it returns this. Okay. Now I want to check and make sure that this is actually the same as what's in appdata.h, the same prototype that's in the specification. So I'm going to go into appdata.h and make sure that I haven't mucked with this indall. And so, so notice that we actually don't return a value out of the copy constructor. I had forgotten that. Ampersand original. And so I'm going to go back into the .cpp and we're going to alter this. And that matches the copy constructor. Go back into the .h, make sure that that indeed is actually what I wanted. And it is. And so now I'm going to recompile. Oh, and I forgot to get rid of the return value because I'm not returning anything now. So down to here, get rid of this. Oh, yeah. Constructors don't have returns in them, even if the return doesn't return anything. So now we're set to execute. Oh, missed a new line right there. But otherwise, the queue contents printed out correctly. That's awesome. I like that. So I'm going to go back into test.cpp. That's not test.cpp, test.cpp. Okay. And then right here, put in an ENDL, recompile, rerun. And there we go. That looks a little better. That means that pretty much everything is working the way it should be. So with that, I'm going to go into appdata.h and just walk you through this again. So we have a max name length of 18 characters. We have a max number of items of 21 items. Our class shopper, which is down here, is also aliased, if you want to think about it that way. It is also named or can be referred to as app data. So our class shopper has a public area, which has a constructor, a destructor, a copy constructor, okay, an assignment operator overload, and a stream insertion operator overload, a stream extraction operator overload. And so that stream extraction operator overload has to follow the format as it was laid out in Program 7's write-up, okay? And I'm pretty sure I did that correctly, but I haven't tested it. We have mutators. So we've got these three mutators: set last name, set valued shopper, and set cart. Okay. And then we have the getters, which is get last name, get valued shopper, get number of items. So remember, the setter for the cart sets both the number of items and what those items are. So this is like a dual purpose mutator, a dual purpose setter. And so here we have separate getters though for those two things, get the number of items. And then this is because of those problems we have with arrays. Arrays, passing back arrays as the result or the return type of a function is actually not easy. It's ugly. And there's a lot of problems with memory allocation and scoping. And so it's much easier to write this as a get a single item and tell it which item to get. So if I've got 12 items in my shopping cart, I can get item 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 11. But I've got code in there to protect it so that I can't get 12 or 13 or 15 or 21. And then we've got our private data, okay, which has our last name, which is max name length plus 1, because you need that 1 right here for the stream, or for the null terminator for the string. We have a Boolean for valued shopper right there. And we have the number of items, and we have our cart that is sized by the max number of items. Okay, so let's get out of here. We'll go into the .cpp part. Okay, so up here is our constructor. Our constructor just initializes things. That's it. The destructor, since there's no dynamically allocated memory, the destructor doesn't have anything to do. We have a copy constructor right here, and it copies everything from original into the current object, or the this object. We have an assignment operator, which copies stuff from the right-hand side into this and then returns this so that we can chain assignment operators together. I have an operator overload for the stream insertion operator. I have an operator overload for the stream extraction operator. So this will allow me to read in a shopper and a cart from the input file, okay? I have a set last name, a set valued shopper, a set cart, where num gets checked to make sure it's not greater than max items. Ooh, I just realized I didn't check a condition here. So if num is less than or equal to 0, or num is greater than max items. So if either one of those occurs, oh wait, I did have that. Never mind. I should read a little further ahead in my code. I returned those as different errors. So a return value of 1 means that we had too many items, and a return value of -1 means we had a 0 or negative number. So I forgot I had done that. And otherwise, we copy over the nums, and then we set the cart to the contents of the array. Okay. And if at any point in copying over the array contents, we hit a value that is not valid for an item number, then we return an error. So return value of 2. Okay. Otherwise, we return 0 saying, nope, nothing bad happened. And then our getters are pretty straightforward. Get last name just returns a reference to the last name string. Get valued shopper returns that. Get number of items returns that. And then the getter specific to the slot number, this doesn't have any error checking in it. And so I'm going to put in a note here, you do this. And so you need to check that slot to make sure the slot is the index into the cart. And so you got to make sure that that slot is valid. That is, your slot has to be not less than 0 and not greater than or equal to num items. Okay, so I just verbally described the code that you need to put in there, but I'm going to leave that like that. You'll need to do so I'm actually going to make this a little bit more obvious. You need to do bounds checking on slot. Okay. And there we go. Now I will post appdata.h, appdata.cpp, and test.cpp to Moodle. Now the reason that I'm doing that is simply so that you have a starting point for your code. You're going to have to implement the queue, but that code, most of that code has already been seen in an earlier lecture. You're going to have to implement the operator overload for the stream insertion operator for the queue. It's basically the same code that's sitting there already that I gave you for print queue. And that was, I think, 3 or 4 lectures ago. Okay, so that is that. So back to the blank screen here. I've got about 15 minutes left, and so we're going to continue on with the linked list PowerPoints that we were doing just the other day. Okay. So I got to get this set up and get the share going. Here's my share. And we were approximately here. So I'm going to start from this slide. So the list item type in a linked list, so remember, this is linked list. This is not what you're doing for your queue program. List item type is is a different name for app data. So we called it app data in the stack and the queue. Now we're going to call it list item type. And so for that class, we can do the same thing that we did in the queue with the shopper, or we did in the example for the stack where we used, I think we just called it app data in that one. So we're going to use namespace standard. We're going to define a class. So this is the specification. It's going to have a constructor, a destructor, a copy constructor, an equal sign operator overload, and a stream insertion operator overload. And then in private data, it's going to have an ID and a salary. And so we really should have accessors and mutators for the ID and the salary. And so that's, you know, an exercise left up to the reader or to you. If you want to use this, you're going to need a set ID, a get ID, a set salary, and a get salary. Okay. So going down, linked data representation. Generally, linked data structures can either be statically or dynamically allocated. The natural implementation is dynamically allocated using pointers. And due to machine or application constraints, sometimes we do static allocation. Okay, so we've covered this already, linked lists, and we covered how insertion works. So you remember all this with, is it alphabetical or is it numerical? It turns out it was alphabetical. We link all that stuff in, right? Okay. And this, I want to go back over again carefully. So this relates back to that list item type that I just showed you, right? So list item type right here, not only should it have a getter and setter for ID and a getter and setter for salary, but it should have a way of comparing these. That is the relational operator overloads. And there are 6 relational operators, and all 6 need to be overloaded. So let's go back down here to that slide. So if you're overloading the relational operators, it doesn't matter if you only need one, you should overload them all. And you only write code for one of them, and there's a reason for this. If I write the code for A less than B, and maybe this says string compares in it because you're doing alphabetical by last name and then by first name and then by middle name, or maybe you're doing just numerical order on an ID number. Whatever you're doing, you write the code to return true or false on less than. So is A less than B? And then you define greater than using less than, and you define equal to using less than, and then you define less than or equal to by using less than, and then you define A or greater than or equal to by using less than, and then you define not equal to by using less than. You only use less than. Why? Well, it turns out if I only have to write the code for A less than B, and I only have to debug the code for A less than B, and I write my other relational operators in terms of, or only using less than, then all I have to do later is change the relational operator overload for less than, and all the others will change along with it. So if I've got a mistake, I don't have to track down that mistake across all 6 operators. If I change the way that they're being ordered, so let's go back to that example. Maybe I wanted these ordered by numerical instead of alphabetical. Then all I would have to do is change the less than, and all the rest would change essentially automatically for me. So that's why I highly advocate that you write just the less than, and then you write the others in terms of less than. Okay, so let's get out of the PowerPoint slides for just a bit, and I'm going to share out that terminal window again. Okay, and you know, I'm going to show you what that code looks like just in a temp file. So temp.cpp, okay, and I'm just going to give you function sort of pretend functions. Okay, these functions aren't actually useful except for illustrating what I'm talking about. So I've got this Boolean, okay? It's an operator overload. So let's call this list item type, okay? And I've got to try to remember buyer beware, caveat emptor, your mileage may vary. Pretty sure that this is the correct syntax for doing this operator overload. There's a left-hand side and a right-hand side, and let me see if I can find an example real quick in my textbook. So this is not our textbook. This is the book that I use for as a reference for all the operator overloads, because overloading operators is kind of funky stuff. So operator overloading. Less than operation. So bool. Compilation. String insertion, string extraction, relational operators. Oh, oof, that book does those weirdly. So the book that I'm looking at does them as not being part of the class. Yeah, it looks like I've got this syntax correct. So pardon me for that little diversion, but so how am I going to do this? Well, I'm going to assume that a list item type has a last name, first name, and middle initial. So I'm going to do this as if we are keeping things in alphabetical order. So if the left-hand side is less than the right-hand side, so if str cmp of LHS, comma, RHS. Now the string compare gives you a negative if the first parameter is alphabetically before the second, a 0 if they're equal, and a positive number if the first parameter is greater than the second parameter. So what we want for the less than operator is for this to be negative, okay? If it's not, then we need to return false, okay? So right here, so right up here, I'm going to check the false condition. So if the string compare is greater than or equal to 0, so that means either they're equal or the left-hand side is alphabetically after the right-hand side, then we are going to return false, okay? And then we have an else if. So by the time we get to this else if, we know that the left-hand side was indeed less than the right-hand side. Oops, I need the dot last name in here. Okay, completely forgot about that. Now we're going to do the same thing, string compare, but now we're going to do it on the first names. So dot first name, comma, and then the right-hand side, dot first name. And the same thing, if it's greater than or equal to 0, then we know that the left-hand side is not less than the right-hand side, and so we're going to return false again. Now the middle initial is just going to be a single character. So I actually can use the less than sign for this. So LHS.mi is less than RHS dot mi. So if that indeed is true, that the left-hand side middle initial is less than the right-hand side middle initial, then we're going to return true. Else, we're going to return false. Okay. So that would be, so I'm right close to 50 minutes right now, but that would be our less than operation to keep alphabetical order, to test alphabetical order of the left-hand side of the less than sign versus the right-hand side. And now, if I were going to overload those other relational operators, bool list item type operator greater than const ampersand list item type LHS const list item type reference RHS, return RHS less than LHS. That, my friends, is that. So by redefining these operator overloads, so doing the less than right here, now I can rewrite all the rest using that. And in fact, if I do this, so this is the last thing I'm going to do tonight. I'm going to go and grab this. So this is going to be 5 lines that I want to copy. Okay. And then here, I want to do this as equal to. And then I want to do less than or equal to. And I want to do greater than or equal to. And I want to do not equal to. Okay. And then for each one of these, I'm going to rewrite what I'm returning to fit that Boolean algebra or the Boolean logic that I had before. Okay. So I'm just reading off the PowerPoint slides right now, but this is not LHS less than RHS and not RHS less than LHS. So that's the equivalent of equal to. The equivalent of less than or equal to is not RHS less than LHS. The equivalent to greater than or equal to is not LHS less than RHS. And the equivalent to not equal to is LHS less than RHS or RHS less than LHS. So I read those right off the PowerPoint slides. That's all of your operator overloads for relational operators. If I change what's going on up here, all of these change because they use the less than sign and only the less than sign. So that's how easy that is. Okay. And I'll see you next week. Remember, there's an SI session on Sunday if you need help. I am answering emails. You know, I'm not going anywhere. I haven't went anywhere for 17 days. So I expect to be at home answering emails and working. So have a good one. Stay safe. Stay healthy. Stay home. And for your classes, stay engaged. So catch you next week.